Morning, guys. Hope you all doing well. I'm Gospel Gabriel. I'm from MSc Microbiology second year in Central University of Tamil Nadu. Today, I'm going to deal general wastewater characteristics. The table of contents are introduction, physical characteristics, chemical characteristics, biological characteristics, conclusion. Introduction. Wastewater refers to any water that has been adversely affected in quality by human influence, typically originated from either domestic or industrial or agricultural sources. So, why will we need to understand the characteristics of wastewater? Because it is very crucial that it will effective treatment and management. So we will know the characteristics of wastewater to ensure and to protect our environmental and also the public health. For what? That is a question when comes if we going to do any studies. We have 3 points: effective treatment processes, environmental protection, public health safeguarding. Here, the wastewater are characterized into three types. One is physical, second one is chemical, and third one is biological. So before we're going to see about the characteristics, we're going to know about sources because sources are very essential to determine the characteristics. Here, three sources generally. First one is domestic water and industrial wastewater. Third one is storm sewage. What is domestic water? Basically, everything that comes from house is generally referred as domestic. So the household wastes like washing utensils, cooking wares, and car wash, bathing waste, etc. are referred to as domestic wastewater. So what are industrial wastewater? They are the liquid discharges from industries. They might have chemical, heavy metals, toxic components, either different type of pollutants, etc. And here comes the storm sewage. It includes surface runoff generated by rainfall because when it rains, we can able to see floods everywhere. And that excessive runoff water will mix into the sewages and drains, and it will going to end up in water bodies eventually. So the major sources of water pollutants are from human settlements and industrial and also agricultural activities. 80% of the sewage in developing countries is discharged untreated directly into water bodies. There is no awareness. So, industry dumps are estimated to 300 to 400 MT of polluted wastewater in normal waters every year. Nitrate from agriculture is the most common chemical contaminant in the world's groundwater. So there is two type of water, black water and gray water. Black water is basically from urine and feces from household, which is domestic, and gray water is coming from washing, bathing, and kitchen wastes. These are all the types of domestic wastewater. The physical characteristics of wastewater are color, odor, temperature, turbidity, and total solids. So, the color. The color of fresh domestic sewage ranges from gray or green or yellowish color. But as the time elapses and due to the putrefaction process, it turns into black color. Here comes odor. Fresh sewage has less odor, which is very less offensive, but as it ages and the stagnant overcomes, it will gradually releases an offensive odor which is unpleasant and unbearable. As all the available oxygen is depleted for the microbes, it will stop to release a melodromous combination of hydrogen sulfide gas and other sulfide compounds which are generated by anaerobic microorganisms due to the depletion of oxygen present in it. Let's see temperature. The temperature is nearly 20 degrees centigrade in almost all the wastewater. As the temperature increases, viscosity also increases. The wastewater will have naturally or normally high temperature than conventional water. So more temperature, there will be more biological activity. Turbidity. It is a measure of cloudiness of wastewater due to the presence of suspended solids. This depends on the quantity of suspended solid particle within the system. This turbidity is act as an indicator of light emitting characteristics of wastewater. It is also an indicator of efficiency of sedimentation and filtration in treatment processes. It affects the penetration of light into the water body, impacting aquatic plant life, because without light there will be no photosynthesis and there will be no food for plants. So the turbidity of sewage increases proportionally with its strength or concentration. The measurement of turbidity can be conducted using a turbidity rod or Jackson's turbidometer. Here the turbidity is less, which is referred as clear, and here as it goes on it becomes very high, which is referred to as murky. Here also low turbidity, high turbidity. Let's see about total suspended solids. So a normal water content is 99% of water in wastewater and solid is 0.1 percentage. So in that 0.1 percentage, the total suspended solids is defined as mm, after evaporation, completely evaporation, the things which will remain in over there is called as total suspended solids. It is defined analytically as all the stuff that is left behind as residue after evaporation at temperature between 100 degree and 105 degrees Celsius is defined as total suspended solids. So TSS can lead to the formation of sludge in water bodies, which are very disrupting to ecosystem. These are three types. One is total solids, another one is total suspended solids, another one is total dissolved solids. So here we can able to see the total solid, which is the residual matter left behind after the evaporation of water without any filtration. There is no filtration done. That is called total solids. So what is total suspended solid? If the water sample undergo filtration and dried, after the residues on the filter membrane, the residues present above the filter membrane, such as glass fiber filter, is referred to as total suspended solids. So, what is total dissolved solids? TDS. The particle obtained from the evaporated filtrate. Here we can able to see the TDS. Let us let us talk about the conductivity of wastewater. So the conductivity is the measure of the ability of wastewater to conduct electricity. Directly, it is related to the concentration of dissolved ions, which is salt. So high conductivity will indicate the presence of higher amount of salts, which will affect both biological treatment and also the soil quality. So this conductivity also used to monitor salinity levels, especially in region prone to saline intrusion. So it is a key parameter in assessing the suitability of treated water. Either we have to reuse or we have to discharge it. So this fluctuation in conductivity can indicate changes in industrial discharge or treatment efficiency. This is all about the conductivity of fresh water. Here you can see this is the meter you can use to check the conductivity of fresh wastewater. So here industrial site from wastewater is collected. It is full scale digested. Here anaerobic sludge, and we can see electrical conductivity test, which will observe the result and it will give us high and low. This is all about conductivity of wastewater. Let's see the chemical characteristics due to the chemical impurities. There are chemical oxygen demand, which is referred as COD, total organic compound, nitrogen, phosphorus, chloride, sulfate, alkalinity, pH, heavy metals, trace elements, and priority pollutants. Let us come to chemical oxygen demand COD. What it refers? It is the amount of oxygen required to oxidize all soluble and insoluble organic compound present in volume of water. So this QOD is usually expressed in milligram per water, which is mg per ml. So how COD test is done? A COD test indirectly measures the concentration of organic compound in a sample of water by measuring the amount of oxygen required for oxidation of all the organic compound present in the sample. So, the common technique which uses COD vials for measurement and result are typically achieved within 2-3 hours, which is faster than comparatively than the BOD. So, the COD vials we cannot able to discard it anywhere and we have to return it to the company for the reuse. So what is the application of COD? So it is used to determine the concentration of oxidable pollutants present in wastewater. It acts as an index to determine overall water quality. So to determine the effect of wastewater disposal on receiving environment. So COD is usually higher than BOD as it includes both biodegradable and also non-biodegradable substances. So high COD level can indicate high pollution load and potential for environmental damage. Let us see about total organic compound. What is total organic carbon? So TOC is a measurement of total amount of organic compound found in a water or soil sample. A high TOC level often indicates high level of organic pollutants. So how it is done? It is done in three methods. First one is sample preparation, second one is oxidation, third one is detection. In sample preparation, what we will do, we will collect the sample, we will pre-treat it like filtration or acidification to remove the interfering substances or to separate organic and inorganic carbons. So oxidation, so oxidation is two type. One is thermal oxidation and the chemical oxidation. This thermal oxidation use substance like catalyst to speed up the reaction. It will happen at high temperature above 680 degrees centigrade approximately. So what is chemical oxidation? So here it uses chemicals such as sodium persulfate or UV light are used to oxidize the organic compound. Detection, how we able to detect? Two type of detection, one is infrared and another one is conductivity detection. Mostly TOC analyzers are non-dispersive infrared NDIR sensor is used to measure the organic carbon content. So conductivity, it will use CO2 to measure the conductivity and through it will form carbonic acid. So by this way, it will detect the total organic carbon. So these are the conventional method, which are standardized method for measuring the pollutants COD, BOD5, TOC. But these are modified into this type like oxidation, detection method, new techniques, biosensor, bioreactor, miniatured systems, conductivity, CO2 electrode, UVVS. These are all modification of these standard methods. Why we need to have faster, sensitive, and better environmental techniques. That's why these conventional methods are modified to better methods. So let's see pH value. So RAS pH has pH between 7.3 and 7.5, which is alkaline in nature. So with the time increases, the bacterial production will be very high. So as bacteria increases, the production of pH value going to drop as the sewage becomes more acidic in nature. Later, due to oxidization of this bacteria, will oxidize the pollutant, it will become alkaline again. So what, let's see chloride content. What are the chloride contents? The sources of chloride are the leaching of chloride containing rocks and sewage from human faces, culinary waste and urinary discharge. These are all the chloride content present in the wastewater. So nitrogen content. What are the nitrogen present in wastewater? There are really four types. So before we see, we're going to see general thing. Nitrogen in sewage is a clear sign of decaying organic materials. So nitrogen is often known as nutrient or biostimulant. It is crucial for development of protista and plants. So here ammonium nitrogen or free ammonia. The initial phase of organic matter decomposition is observed through ammonia and nitrogen or free nitrogen. We can able to detect if it is there, if it is present, this is the state. So organic nitrogen, how we know whether organic nitrogen is there or not? We can able to detect it by Ketchedal method. So nitrite, nitrogen. Nitrites are indicator there is an organic depression that has partially degraded. So here the nitrates, which is an indicator of the existing organic matter that has been entirely oxidized. If it is entirely oxidized, nitrate nitrogen will be produced. Surfactants. So synthetic detergents are the primary source of surfactants. These surfactants are the byproducts of indoor plumbing, appliances, and also lot of electronics. So here large organic molecules are generally referred to as surfactants. These are surface active agents. They produce foaming during the wastewater treatment. So the we have to remove the foam constantly if there is the presence of surfactants over there. A standard solution of methylene blue dye used to quantify the amount of surfactant present in the wastewater. Let us see about toxic compounds. What are all the toxic compounds which may present in wastewater? It is like copper, lead, silver, chromium, arsenic, boron. These are all coming under cations, which is toxic in nature. So what are the anions? Mostly cyanides and chromates are the anion which are coming under toxic components. So what are, let's see about sulfate, sulfide and H2S gas. Sulfate ions referred to as SO4 are naturally present in majority of supplies of wastewater. And also sulfur, it is an essential element which is responsible for protein synthesis, is also liberated during the process of degradation. The production of hydrogen sulfide gas result in smelly and also offensive byproduct, which we already see in the physical characteristics of odor. So here the H2S gas undergoes biological oxidation, produce sulfuric acid H2SO4, which also result in the corrosion of sewer pipes. This is all about the sulfate, sulfide and H2S gas. Let's see about salinity. So this salinity is basically referred as total dissolved solid, which is TDS. So basically every people will ask what is the presence of TDS in your water. It may be also used to put RO water also, RO system also. They will check for the amount of TDS, then only they will select the RO machines. So This TDS will tell us. This TDS will tell us the amount of salt water present in salt which is present in wastewater. High salinity can affect biological treatment processes and also soil quality if this water is going to use it for the irrigation purposes. And these common salts may include potassium, sodium, chloride, and sulfates. We already see some of them on the sulfates. So high TDS level can come from both industrial discharge, saline intrusion, or from any kind of domestical sources. This salinity must be controlled to prevent damage to aquatic ecosystem and reduce the corrosive nature of wastewater. For this, the salinity is measured. So the TDS is basically measured in parts per million. If it is around 300 to 600, the water is referred to as good condition. 600 to 900, it is fair, okay, but 900 to 1200 it is very poor, and above 1200 it is unacceptable amount of TDS, and anything nothing can be done to that. So let us see about biological characteristics of wastewater. There are a lot of biological characteristics, but we are going to see important among all of them. What are they? Microbial population, biochemical oxygen demand, nitrogen load. We're going to see about nitrogen and also phosphorus, organic matter, biomass concentration, and then finally enzymatic activity. What is microbial population? The wastewater contain a wide range of microorganisms, which may be bacteria, protozoa, fungi, algal, and viruses. Bacteria are most important in wastewater treatment as they break down most of the organic matter through either aerobic or anaerobic processes. It depends upon the bacteria which is present there. If it is aerobic bacteria, it will work on aerobic process. If it is anaerobic bacteria, it will work on anaerobic process. So later the protozoa help removal of suspended solid like TDS etc. by consuming bacteria and other organic matters. Fungi are involved in degrading complex organic compound, particularly wherever low nutrient environment is available. Algae, this algae contribute oxygen to aerobic processes, but also cause issues like algal bloom to open treatment system where this algae grow fully and it will affect the entry of light to go inside. It will cause various troubles. Here we see biochemical oxygen demand, BOD. So BOD is a measure of amount of oxygen required by microorganisms to decompose organic matter in wastewater, where high BOD level indicates a large amount of biodegradable organic material which can lead to oxygen depletion in water bodies. BOD is critical for designing biological treatment systems, assessing the efficiency of this system. A low BOD in effluent indicates effective organic matter for removal for reducing the environmental impacts. It is a key regulatory parameter in determining the quality of treated wastewater before discharging. BOD level in basically measured in mg per liter. So 1 to 2 mg per liter, it is referred as very good. And there will be not much organic matter present in that water supply. If the BOD content is from 3 to 5, it is referred as fair. It's okay. The water is moderately clean and somewhat around. If it is come from 6 to 9, then it is referred to as poor water. somewhat it may be polluted at some point. So it usually indicates that organic matter present and microorganisms are decomposing the water. So if you drink it, it must be containing microbes in it. So BOD level is 100 mg or more. It is very poor and it is very polluted, containing more amounts of organic matter. So this is the graph how we going to get BOD. Nutrient load, nitrogen and phosphorus. So nitrogen and phosphorus are key nutrient found in wastewater. It mainly comes from either domestic sewage or also industrial discharges. This high level of nutrient can lead to eutrophication where the water is received constantly, which will cause excessive algal growth because algal will use this nutrient and grow excessively, and it will cause oxygen depletion in some water bodies because light cannot be allowed inside the water bodies. So the plankton, phytoplankton present inside the water body cannot able to produce oxygen. This is the real problem. Nitrogen is typically found as ammonia, nitrate, and organic nitrogen, while phosphorus occurs in both organic and also in inorganic forms. Biological treatment process such as nitrification and denitrification will help to remove nitrogen. Phosphorus removal is done through either chemical or also biological processes. Here, regulatory limits on nutrient discharge are enforced to prevent further environmental degradation. Organic matter. Wastewater contain significant amount of organic matter. Include what it does have: new protein, carbohydrate, fats, oil from both domestic and also from industrial sources. Organic matter is key food source for microorganisms in any biological treatment process. The biodegradability of organic matter determines how efficiently it can be treated by microbiological activity. Organic matter is measured in the following parameters like BOD, COD or TOC, which we already see. So excessive organic matter can deplete oxygen level in natural water body, leading to environmental issues like fish kills. Biomass concentration. Biomass in wastewater treatment refer to total mass of microorganism which has bacteria, protozoa, algae, fungi, etc., which are all involved in breaking down organic matter. A higher biomass concentration which will enhance the efficiency of biological treatment process like activated sludge or biofilm reactors. Maintaining a healthy microbial population is very much important, and it is crucial for the continuous degradation of organic pollutant because they break down most of the organic compounds. Biomass concentration is monitored to parameter like volatile suspended solid VSS and mixed liquid suspended solid MLSS. So here proper control of biomass help to prevent issues like sludge bulking, and also the controlling of biomass will help in consistent treatment performance. Here comes the enzymatic activity. Here, microorganisms in wastewater treatment produce enzymes that can break down complex organic compounds into much more simpler molecules. Enzymatic activity is crucial for the degradation of proteins, fats, carbohydrates, and other organic pollutants. Different enzymes are produced under aerobic and also anaerobic conditions, contributing to the efficiency of both type of biological treatment processes. Enzyme activity help to speed up the decomposition of organic matter, making the wastewater treatment faster and also more effective. Monitoring enzyme activity can provide insights into the health and efficiency of the microbial community in treatment systems. Here, Enzymes utilized in wastewater treatment, basically oxidoreductase. Some examples are here like peroxidase, lignin peroxidase, etc. Ligase, hydrolysase, pectase, amylase, protease, cellulase, which are all the most common enzymes present in the treatment of wastewater plants. So these are my references. Thanks for listening. I'd like to thank Dr. Kavya ma'am for giving me this wonderful opportunity. And also, I would like to thank my classmates where they are very supportive and they are very encouraging and they are best friends that I ever had. Thank you so much, guys.